Yes.
Bismillahirrahmanirrahim. ठीक है, ये चल रहा है, ठीक है. So, what I would like to, the title of the seminar is Methodological Mistakes and Econometric Consequences. It just means that there was a fundamental mistake that was made in creating the current methodology of econometrics. This mistake is currently embedded in the way that we teach and we think about and we do econometrics. And because of this mistake, econometric results cannot give us the satisfaction that we have proven something. And there are many people who have said, okay, we have been doing this for 100 years and we have not received any positive result from econometrics, so we should just throw it in the garbage. So I would like to clarify. So there are two fundamental errors. Actually there is one more, but we can't. Anyway, so there are two fundamental errors. And what are these fundamental mistakes? One is that we focus on observables, the numbers, instead of the reality behind the numbers. Why did they occur? Why was this fundamental mistake made? Well, it was because of the influence of logical positivism. And what are the consequences? That in econometrics we are trying to find patterns in the data instead of looking for real causal structure. So when we want to analyze money demand, we look at the pattern, the data on prices, and we look at the data on money, and we run regressions. When in fact what one needs to do is to see what happens in the real world when money is printed. So that's, and who does it go to, what do they do with it, how are prices formed. These are all real factors. These are not, we don't look for that. We look only at the numbers and we look at the patterns and we see if we can fit a regression and we base our conclusion. So this is why, that's the surface phenomena. The numbers are the surface phenomena and the reality is the more complex and messy and often non-quantifiable. And so this is the mistake. Okay, so I think we did this, we covered this, that the rise and fall of logical positivism is a very important story, which I will not tell in this talk. Actually, that's something which also needs to be understood, and the history of how it emerged and what happened and why it was rejected. All of these are very important topics, but since they are not directly related to econometrics, I will have to bypass them. But that's a good story for to understand. If we want to understand the structure of Western knowledge at this time, it is essential to understand this story. So basically, I've outlined this last time also, that there was a quest to prove that science is superior. And these philosophers invented to prove this, and actually it succeeded perfectly, and it proved that science is knowledge and everything else is not knowledge. But in fact this proof was wrong and the philosophy was wrong. But on the surface it seems very reasonable that look, there are some unobservables, there is the true reality which nobody can observe, and then there is the observables. So all our reasoning about the true reality is based on what we observe. It's not based on because we don't have access to reality. We only have access to observation. So forget about reality, just talk about observations. This was the basic idea. Knowledge about unobservables is impossible. So here is the picture of the world which is pre-positivist, and that's the true picture, that there is a reality. The reality generates observations, and we use the observations to find out what the reality is. The observations are clues and we put together these clues to discover reality, which may be very complex and very hard to understand. And so we need skill to put together these observations, and it's possible that the observations can be put together in different ways to yield a different picture of reality. But the positivist view eliminated the reality from the picture. It says that all we have is observations, and then we have our logic, and whatever we want to say should be confined to observations and logic. The facts and the observations is all there is. There is no knowledge of reality that is possible. So, this led to a wrong understanding of science. See, as I discussed last time, there is the nominalist view. Okay, so we have the understanding that the earth revolves around the sun due to gravity. Now, gravity is the real cause. It is an unknown force, unobservable. Now, the positivist understanding says that you can't talk about unobservables. So, now, what the positivist view says is that basically gravity, whether it exists or it doesn't exist, doesn't matter. We only look at the observable effect. The observable effect is that the earth must move around the sun in an elliptical orbit. So basically, then gravity means that the observation, that the pattern of motion is followed by certain equations. That's all it means. We don't know anything about gravity. Now, when you go to physics, the physicists are realists. They say that there is a force like gravity. If there was no force, then it wouldn't work. The earth would not go around. Similarly, there are many unobserved, like electrons, quantum forces, etc. And the physicists are all realists. They believe that these things exist. But the philosophers of science said that no, they can believe those things exist, but it doesn't really matter. The methodology doesn't depend on whether or not gravity is real. It only depends on the observable patterns. So, there emerged a wrong understanding of what science is. The idea emerged, and it's explained, the philosopher of science said, Nagel, that basically science is about looking for patterns in the data. If you find a pattern, then you predict that this pattern will continue, and that is what science is. This is wrong understanding of science. Scientists are looking for explanation. They're not looking for patterns, they're looking for the why. Why is this pattern there? The earth goes around the sun in an ellipse, but why does it go around? Well, that's because if there is a force of gravitation, it would cause elliptical motion. So from the pattern, they deduce the existence of reality. Again, note how very closely similar this whole thing is to the idea of religion. We look at the world and the symmetry and the harmony, and from this we deduce that there exists God who created it. Now what the positivists say is that no, the pattern is all there is. You cannot go back and deduce something which is unobservable from the observable. So basically this was the battle, and it was won by the positivists. Positivist idea was accepted that we can't deduce the unobservable from the observable. We must confine all our thinking and all our reasoning to the observable. There is no point in talking about unobservables because we have no access to unobservables. So there were many consequences of this strong description, and we have discussed these in much greater detail last time. So many internal human motivations which are unobservable were thrown out of the picture by behavioral psychology. Probability theory was very deeply affected. You see, when I flip a coin, it can come up heads. The probability of heads is equal to 1/2. We all understand this intuitively, because you see, if you go out and play football or cricket, they flip a coin and they decide who is going to go first, who is going to have the batting. Now, it is understood by both parties that the chances are equal that one party can win or the other party can win. It does not have to do anything. Neither of the parties, when they are flipping a coin, have the idea that we must flip this an infinite number of times and look at the limit of what happens. They understand probability on that particular coin flip. They don't understand it with reference to a sequence. So why did this apparently absurd definition of probability, why is it currently the most dominant definition, the one that is most widely used? Why? Well, because of positivism. Because when you say that the coin came up heads, but it could have come up tails equally, possibly, this is unobservable. You have to understand. This is something which might have happened, but which didn't. Because it might have happened, it could never have been observed. So this definition was immediately rejected. It refers to an unobservable event, so it's nonsense. It doesn't have any meaning. According to positivist theory, this sentence is meaningless, that it could have come up heads. So when the natural definition of probability was blocked by positivism, then they had to come up with what is observable. So the only thing observable about probability is that if you keep flipping the coin, ultimately the ratio of heads will converge to 1/2. So this was made the definition of probability because there was no option. There was nothing else that is observable. Similarly, causality is unobservable. Because if something causes B, it means that when I put something in the fire, it will burn. It means that this is something which necessarily happens. Now what can be observed is correlation, that X happens and then Y happens, and you can see this many times. So you can see sequencing, but causality is deeper. It refers to some real mechanism, some real cause which is underlying. And you can observe that somebody smokes and then he gets cancer. Smoke cancer. So then you say that smoking is the cause of cancer, but that is not what we mean by causation. What we mean by causation is that smoking will cause certain changes in the lungs, and it will weaken certain bodily defenses, and you have to go through the mechanism in order to prove causality. So, but you can observe correlation. So in econometrics, causality was forgotten, and yet causality is everything. To give an example which is econometrically useful, if you run a correlation in the WDI data between newspapers per capita and GNP per capita, you find a very strong correlation. So you can say that if this is a causal effect, then you can say that okay, the way to increase our GDP is to publish more newspapers. But of course this is not true. There is a much weaker correlation between expenditure on education 10 years ago and current income levels. So if you just go on correlations, then the newspaper strategy is the right strategy for growth. But if you look at causality, then the educational strategy works better. And yet, economists don't have, in our current econometric methodology, we have no way of distinguishing between these two things. Because our methodology is entirely positivist, only looks at the numbers, doesn't go underneath to see about causal change. There is no mention of this issue in econometrics textbooks. So there is this word rhetoric, which you may have heard. This word rhetoric today is used in a bad way. Rhetoric is just using hot air to support arguments. This is what the current understanding of it. So you may be surprised to know rhetoric was considered a very valuable and important skill, and it was taught in colleges and universities. There were courses, there are still books on rhetoric, and I think it's still taught in madrasas, but it has been dropped from the curriculum. There are no courses on rhetoric, even though it's a very important skill. Why? Well, because the positivist view, the pre-positivist view said that there are facts, but you use these facts to create a picture of reality. This requires skill. You have to assemble the facts in the right way, and then that is the job of the rhetoric, that you can present the facts in an attractive way and make them persuasive. Because facts by themselves don't determine reality. You can, but now in the positivist world, the facts by themselves determine reality. There is nothing more you can add. So now rhetoric become bad because the idea was that you use the facts but you distort them. The positivist picture was the facts is all there is. Once you have the facts, then you know everything. So everyone will automatically agree. So then rhetoric is a way to distort the facts. You hide some of them, and that way you create an argument where there would be no argument if everybody knew all the facts, because all the facts would automatically determine the reality. So rhetoric went from being a good word and a valuable skill to a bad word and a way of deception. So actually, statistics is rhetoric. It is the way, it is how to persuade people using numbers. And there are many ways to do this, but current positivist mentality does not allow us to view the subject in this way. So I already discussed Samuelson's mistake, that the observable choice was taken as a replacement for the feeling of preference in the heart, but in fact it doesn't work. And in fact this has been pointed out by Stanley Wong in a book which he wrote on this whole topic of how revealed preference theory doesn't actually work to do what it is supposed to be doing. It cannot eliminate the preference. So now all of this was tamheed, preliminary work, to get to our topic, which is how this applies to econometrics. So basically, the main issue is that current econometrics is about looking for patterns in the data, and it doesn't go beyond that. And the real thing that we need is to look for clues about reality. What is the data telling us about the real world? So we remember the diagram that I had earlier, where we have the data and then we have reality. So the data furnishes us with some clues, and we have to follow up. We have to see, is this a clue? Sometimes the clues can be misleading, and so the data can be telling us something, but the reality is quite different. And we have to work on how to relate. We have to look at the relationship between the data and the reality to make any progress. Current economics doesn't go beyond just looking at the data. It doesn't go to the underlying mechanism. The econometrician, after running a regression in which the price increases are highly correlated with money, doesn't go back and says, okay, this is the process by which money is printed, and then it goes into the hands of the consumers, and then they make purchases, and when the manufacturers see that there is excess demand, then they raise prices. All of these are possible mechanisms, but if we are realists, then we would go and check, is it true that the manufacturers raise prices? We would go and see, and some manufacturers can raise prices, some cannot. We would have to go into the details of this in order to understand whether or not this regression furnishes us with the correct clue to reality. But current econometric methodology has nothing like this at all. So what is the difference? Well, in looking for patterns, we can force patterns onto the data. There are many ways to do this. And if we have two different patterns, then there is no real way to say that this is right and that is wrong, because this is one pattern and that's another pattern. I can fit an ARMA model, or I can fit a chaos model, and I can fit different models. How do we compare? Well, there are some statistical techniques, but they really don't help. I mean, I'm saying this as an empirical measure. We have done estimation of different types of consumption functions. Many of them fit nearly well, and you are all familiar with 5 different theories of consumer behavior leading to, there's the permanent consumption, there's the life cycle hypothesis, and there's this, that, rational expectations, many difference. All of them lead to slightly different equations, and we can fit an equation which fits well for all of these theories. And so how we decide which theory is right? We can't on the basis of the R squared, because all of these theories produce a good fit. So there is no way to compare or differentiate. In order to assess, we need to go back to reality and to find out, is it really true that consumers have expectations? Is it really true that they are doing a lifetime maximization? All of these things we can go and find out, but we don't, because the econometrician looks only at the numbers and the regression models. He's not supposed to go behind and look at the real causes. So Kevin Hoover wrote that for 50 years there was no mention of causes. The econometricians don't talk about causes or causality. Then there was this Granger causality, but Granger causality has nothing to do with real causality. It's just a predictability criteria. So basically the idea that the real thing that needs to be done is to look at real causes and structure and mechanism. These things are not done currently. There is the example of Var models. Var models basically represent the abandonment of the idea of finding causality. The previous approach, the simultaneous equations, it had some idea of causality. Although the structural equation modeling of simultaneous equation models, you have to specify in advance what are the endogenous variables and what are the exogenous variables. At least this has a causal structure. But the weakness of that approach is that there is no way, the data is not used to determine what is exogenous and what is endogenous. You have to specify causality in advance. You don't look at the world to find out what the causal structure is. You impose this on advance and then you do the estimation. But at least there is a causal structure. But now the Var models came into existence because people said that these assumptions are often wrong. We assume that this is exogenous, but it is not. We assume this is endogenous, but it is not. So let's just get rid of all of these assumptions. Let's throw out the causal structure of the model. Everything depends on everything. Now, in Var models, for example, so we have current variables depend on lagged values. Now, in IIIE, we had a thesis some time ago in which the person was running a Var model, and basically he had the prices of wheat, the acreage due to wheat, and rainfall and other variables, and he ran a Var model. So now the current price of wheat depends on last year's acreage. The rainfall depends on last year's acreage and last year's price of wheat. But this is what the Var model will do automatically, because this is what it's supposed to do, because we are saying that we don't know anything about the structure, so let's just let the data decide. Now this is ridiculous, and that's what comes of blinding yourself to causality. And these kinds of things happen often. We are running models which are completely ridiculous from the point of view of the real structure, but the econometrics doesn't differentiate, doesn't allow us to differentiate because our methodology is all wrong. There were these huge forecasting competitions in which lots of people participated. There was a journal of forecasting, and basically what was the idea? Idea was that there were many different techniques for forecasting. Some of the popular ones are exponential smoothing, which has many varieties: single, double, whole twinters, damped. And then there are time series models, ARMA, ARMAX. And then there are neural networks and state space methods. All of these methods were tried to find out which method forecasts best. And what they did was they took thousands of real series and then they generated it in the real world, and then they tried all of these methods. This was a competition. People would submit their method that, okay, my method is going to forecast well, and they would take this method and apply it to all the 1,000 real series and see which one works better. Now, actually, what I would like to say is that this was effort wasted on a nonsense question. The question itself, to ask which forecast method works best, is nonsense. But a positivist mindset will not allow you to see that this is a nonsense question. Why is it a nonsense question? Because, I was also trained as an econometrician, so it took me a while to arrive at this understanding that this question being asked itself doesn't make sense. Why? Well, basically, you see, you have some real data. Then you fit a model onto it. How well will this model forecast? Well, that depends on what is the match between this model and the reality which generated this data. It doesn't depend on how good the model is as a fit to the data. It depends on the match between the model and because the reality is generating the data. If there is a real mechanism, are you closely matched to this real mechanism or not? Now, different series have different real mechanisms. So there is no one method which will generate the right model for all series. And so you will get random results. If it hits, it will be good. If it doesn't hit, it will be bad. And there is no system. Sometimes it will hit the real model by chance, and sometimes it will not. And exactly this is what happened. Nothing was learned in these competitions because some models would perform well on some series, not poorly on others. There was no system. There was no exponential smoothing, this is the best method. Why? Because exponential smoothing matches some of the models in reality and not on others. So nothing was learned from these three competitions because there was nothing to learn. Because the basic question, what makes a model forecast better, cannot be addressed by just looking at the data and the model. It has to be addressed by doing something which is outside the range of econometrics. We have to look at what is the real process which is generating the data before we can answer this question. And if you don't answer this question, then it's all useless. There's no way to answer it. So, basically what is econometrics about? It's about finding the best fit to the data. Now, if we have a large collection of models, you can fit any data. So if you have a pattern of data in 2 dimensions, if you fit a line, it might not fit too well. If you fit a quadratic equation, it will definitely fit better. And if you increase the number of polynomials, you can show as a mathematical theorem that the sufficiently high degree polynomial will fit anything perfectly. So there are opposite tendencies. Finding the good fit means that you should find a high degree polynomial. The higher the degree, the better the fit. But actually, the main issue is to find a surprise. Suppose you have some random data on X and Y, and you find that it all lies on a line or close to a line. Well, that's very surprising, because why should it lie on a line? There are 2 variables. They can behave in any different way, But if they are all on a line, then it means that there is something going on here. There must be some relation, there must be some reason, some reality which is producing this line. So now, if you find that the data is in line, you are surprised. Why did this happen? Now you must go and look at reality. Why is this happening? For example, suppose that X is the measurement of heights of people in meters and centimeters, and Y is the height of people in inches. Then you say, now I understand, it's easy. They are just different measures of the same thing, and they should be linear. But if it is something else, like it's consumption and income, then you say, this is a bit surprising. Why is consumption linearly related to income? Maybe it's because the people at the Census Bureau did not have any data on consumption, and they had the GNP data, and they just said, okay, we'll take 80% of this as consumption. If so, then the pattern doesn't mean anything. But if the data has been collected by different agencies, somebody collected the consumption data, somebody else did and now they are matching, now it's a genuine surprise, and you have to go and find out. So, unless you know the mechanism which generated the data, you cannot say anything about what this is going on. But if there is a line, then there is something to investigate. But now you say that, okay, here is some data. I fitted a 6-degree polynomial to this, it fits perfectly. Now let us explain why this relationship exists. And that's nonsense. There's no surprise about this fit. It's a forced fit onto the data, so there's nothing to investigate. So, I will skip Henry methodology, it's a bit complicated. So the main issue, if we take the real approach, then the issue is to find surprises. Why? Is there something about the data which is unusual, unexpected? That's a clue. We use that clue to explore reality. As opposed to this, if we are trying to find good fits, we can use a very complicated model and produce a good fit, and it will be completely meaningless. Because economists are focused on producing good fits, and because good fits can be produced very easily by using complicated and more complicated methods. You see, the more complex the method is, the more it is possible to fit something. So, taking any theory, if we make a very complicated model which represents that theory, we can fit any data. So, I have a student, I asked him to write a thesis on unit root tests, and basically he showed that you can get any result you want, and in fact he shows how. And if you want to show that the series has a unit root, here is the test to use and here's what to do. If you want to show that it doesn't have a unit root, here's the other test to use and here's what you get. Similarly, in causality tests, I have a student, Zahid Asghar, in fact he did this thesis, and he showed that you can get any result you want using Granger causality. There are various 5 or 6 different things you can manipulate, and if you manipulate them, you can change the causality result, you can get any result. Similarly, if you have 2 variables, data series X and Y, and you want to show that X affects Y positively, you can do that. If you want to show it affects negatively, you can also do that. And if you want to show that there is no effect, you can also do that just by introducing the right other regressors in the relationship. You have Y equals alpha plus beta X plus Z. Now the other Z, by choosing the right variable, you can get rid of X, you can make X significant positive, you can make it significant negative, whatever you like. So, basically there's a huge number of tricks that we have when we're trying to fit a relationship. We have auxiliary assumptions, we have specific details. If X doesn't work, I can use log of X. We have various kinds of tests, we have transformations. So basically, by playing with, the number of tools we have is very large. In fact, the title of this slide is taken from Henry's he has said that in a letter that we have the tools to prove anything. Now we have sufficiently complex models that with a finite amount of data we can make it say anything we want. So, to explain this a little bit further, basically, correlation is a surprising thing. Why is it a surprising thing? If we have two series, and whenever one of the series is high, the other one is high. By high I mean relative to its mean. The mean is neutral. Something can be below the mean or above the mean. So if we have two series and they move similar together, whenever one is high, the other is high. Whenever one is low, the other is low. Immediately, this is a surprise. Why do these move together? And now we have to explore. We have to go to the reality and we try to find out what is the relationship. Now, there is a surprise. There must be some reason for this surprise. Let's look for the reason. This is the methodology that I am proposing as what should be the methodology, but it is not. Now, it is well known, all of you have known this, learned this. There is something called spurious correlation. If we have two trending series, both have time trends, then we will find correlation between them. Why is this correlation? Well, it's very simple. Both series are trending upward. The center of the median, the middle of the mean is right in the middle. All of the early observations will be low, all of the late observations will be high, so there is a perfect match. X is always low in the first half and always high in the second half. Y is always low in the first half and always high, so there is a perfect correlation, but it is meaningless. There is no surprise. So, even though we have very high correlation, there is nothing to investigate. We know that this correlation occurs due to artifacts of how we are doing things, and there need not be any relationship between the series. This is what the problem of spurious correlation is, and it has been explained by many people in many different ways, but the essence of it has not been understood. That basically, because there is no surprise, there is nothing to investigate. We know in advance that trending series will be correlated, and this correlation is not surprising. Because it's not surprising, it is meaningless. So, the point I am trying to make is that econometricians are looking for correlations, whereas we should be looking for surprises. And these two are different. So, it is not the fit which matters. It's not the R squared, it's the reason for the fit. When in order to demonstrate this, what I did was I looked for consumption and income series across countries which were well matched, and I found that the consumption in Australia is very strongly related to the income of China. So if you run a regression with consumption in Australia equals alpha plus beta income of China, you get a very good fit. So how did this happen? Wow. Now, why is it? Now we could ask, I could put this regression on the slide and I could ask, now why is it that the consumption of China, the income of China determines the consumption in Australia? R squared is 99%. Well, I will tell you the explanation. The explanation is because I looked through all pairs of countries and I found the best one. So that is the explanation. It means that there is no relationship between the income of China and but if we do it by our conventional econometric thinking, we will say, oh, here is a surprising relationship. So the reason for the fit is because I did a lot of comparisons and I found the reason does not occur in reality. So this is what I am saying, that the current methodology is unable to differentiate. Once I display that equation that look, here is a very good regression, now we have proven that the income of China determines the consumption of Australia. That's ridiculous. So basically the point is that we need to look for when is a good fit a surprise, not so the process by which we found the fit matters. How many equations did you try before getting to this good fit? This is very important. But it is not part, when you display the regression in your publication, you don't tell how many equations I tried before I got to this one. Even though it is essential information if you want to judge how surprising this fit is. So, we get bad results by looking for good fits. Data can provide misleading clues, and in order to assess, we have to look to reality. Here is an example of how data can be misleading. Suppose we have a university in which there were 1,000 male applicants and 1,000 female applicants, and 300 males were admitted and 700 females were admitted. And suppose that, first of all, so it seems like there is discrimination against men and in favor of females, but of course everybody knows that this is not sufficient. It's possible that the pools are not matched. Suppose that all the female applicants are much brighter, they have much higher scores, then this would not mean discrimination. But so that's called the confounding factors. But suppose that, we rule out all of these confounding factors. Suppose that the pools of applicants are well matched and well balanced and comparable. They have similar qualifications. Then it would seem that we have a case of discrimination. The females are preferred. But suppose now we go deeper into the reality. This is what I am saying. You have to explore what's happening in the reality. Suppose we find out that the school has the university has two schools. There is a school of social sciences and school of engineering. The school of social sciences is very easy school to get in. Everybody who applies gets in. Engineering is very tough. And the males always apply in engineering, and the females all apply in social sciences. So this is a breakdown. 900 females applied for social sciences, 100 applies for engineering. So there is no discrimination. Now in engineering, 10% of the females got in, but 22% of the males got in. So discrimination was against the females. Now just earlier we were saying that discrimination is in favor of the females. In the engineering school, there is discrimination against females. They are giving twice as many applications to admissions to males. The same is true in social sciences. 100 males applied to social science, all of them got in. 900 females applied to social science, 690, 77% got in. So again, they are favoring male candidates. So in both the schools you have favor. This is a well-known paradox but it shows what the point that I am trying to make, that when you go to the real mechanism, you find that the discrimination is against females, but the surface analysis shows the opposite thing. So looking at reality this is just a clue. You have to investigate, and on investigation you might find something different. If you look at the structure, the mechanism, what's happening, you have to go to the school, who is applying where, etc. And you have to go to the department, you have to go to the admission committee meeting and see, are they looking at the gender? All of these things are real factors which makes a difference. But the econometrics, if you just look at the numbers and you do the analysis, you will come to the wrong results. So basically, searching for fits without looking at mechanism does not generate knowledge. This is Var. Here is an example. Does the USGNP have unit root? So we have yes by Nelson and Plosser, no by Perron, no by Zivot and Andrews. We can't tell by Rudebush, no by Debord, yes by Murray and Nelson, and no by Papel and Prodan. So this is just different well-known papers, all of them published, coming to 3 different conclusions about a real data series. So what's the truth? I mean, there must be something, but basically the question we are asking is wrong. That can I fit a unit root model to the data? Yes, you can. Can I fit a trend state? Yes, you can. Can I fit a model in which there is neither? Yes, you can. So, as long as the fit is there, we can get any result. The question, what is the real? The hypothesis must be about reality. What is the question that you are asking about the GNP in real terms? If you can formulate that question, then you can answer it. If you are asking about patterns in the data, any pattern can be fit. Does export-led growth hold? So here is export-led growth. There are many papers which prove that yes, if you increase exports, this will lead to growth. There is the other hypothesis, growth-led exports, and there are many papers which prove that that is also true. That if you have growth, that will cause an increase in your exports. And there is bidirectional causality. Again, there are papers which prove this. And there is no causality. Again, there are papers which prove this. So, all of the possible hypotheses can be supported by real publications. We can and we do get any result we want. Purchasing power parity, does it hold, does it not hold? You can find papers on proving anything you like. Is the debt in this country at sustainable levels or not? Again, if you just look at patterns, you can prove anything you like. Efficient markets hypothesis, you can prove it, you can disprove it. Real business cycles, co-integration, all of these things, you can prove it, you can disprove it, and you can find published papers showing exactly the opposite things. So this is obviously a very bad methodology if you can prove anything you like. Now here is I am explaining how you can prove whatever you like. So for example, there is a famous paper which shows that Africa has low growth because they have closed economies. But actually, ROW means rest of the world. Basically, we know that Africa, this is known, the African growth rates are low, rest of the world compared to Africa is high. So just take any criteria at all in which Africa is behind the rest of the world, and you will be able to prove that that criteria is the reason for growth. Because it's correlated, you see. Anything correlates with Africa will, if you run the regression, you can prove that that factor is responsible. So if you can reverse engineer econometrics, you can find out how to prove this factor is responsible for growth by doing this kind of analysis. Maybe this is a little bit too complicated, but basically what I'm saying is that if you understand how a regression equation works, then you can produce any result you want. You can tailor make your regression to prove whatever hypothesis you have in mind. So, what should we do? Well, basically, what is happening in a regression is that we have the data, then we have auxiliary assumptions. What are these auxiliary assumptions? I am assuming a linear model, I am assuming normal Euler terms, I am assuming exogeneity of certain things, endogeneity of other things, and many, many other assumptions. So, the conclusion that I am getting depends on both the assumptions. Is it linear, is it non-linear, functional form, log variable or not, everything. IID errors or ARMA errors, everything that I assume affects my conclusions. But now the positivist mentality says that the assumptions are nothing. You never get to analyze in your econometrics textbooks what happens if I change the assumption. What you do is you say that the data is telling us this. This is basically the mistake, because data is not telling you anything. It is the assumptions, the auxiliary assumptions, which is telling you. So now basically, by changing these auxiliary assumptions, we can get anything we want. So the first thing to do is to minimize these assumptions. If you want to really do analysis, then get rid of, and just look at the data. Don't put any assumptions. So that's why elementary, basic, descriptive data analysis is very important, and that is in fact the course that I'm starting to teach next week. It basically deals with how to look at the data. I don't want to impose any assumptions. I don't want to say that there is linearity. I don't want to say that the error terms are normal. I don't want to say anything. I just want to look at what the data is saying. Describe the data, graph the data. That tells you a lot. And in fact, in that course I also show that if I put a regression equation onto this, how it will systematically mislead you. This is all done with real data sets. I mean, if the data is actually a curve, it's a hyperbolic. Now I run a linear regression, it's going to tell me automatically the wrong thing, because it's not a line. If you look at the data, you would see that it's not a line, but you're not supposed to look. The econometric textbooks don't teach you to look at the data. One of my students did this recently. She was running some regressions and she got significant results, but when you plotted the data, you found that these results are not valid because they are due to certain influence of certain outliers and certain clusters which are distorting the regression. So basically, we should use the simplest possible models. When you use the simplest possible model and something fits, then you have a surprise. Why should the data have a simple description? It should be very complicated. So if there is a simple description, then there must be some reason for this. One of the conclusions, basically in reality, I mean, if we want to have learning, we need to learn about causes. What causes what? Basically all of econometrics depends on this. We have, thousands of papers on growth. Does FDI cause growth? Does export promotion cause growth? Does poverty lead to growth, elimination of poverty, and many, many factors. Every thesis is about does this factor cause growth? And all of them are running regressions, but regressions can never tell us about causality. Causality is always determined by real mechanisms. Sometimes we can get clues. So there is a correct way to do data analysis in which we will get good clues to what the data is trying to tell us. Once we have these clues, then we have to go and double check. It's only half the part. Is this clue giving us the right clue? When we look at the reality, does it match? There are ways to do this if you have the mindset, but the positivist methodology and the current econometric methodology does not generate that mindset. So, elementary descriptive methods are good for providing clues. There are simple things called box plots. There are ANOVA techniques which are good, I mean simple, descriptive, and which allow us to see clues. There are some new graphical techniques. We should not try a lot of different models to produce fit, because guaranteed you can prove that if you try a lot of models, you will find something which fits. And that is an error. If you have, for example, two random series, X and Y, and you are working at 95% level of confidence, then if you try 20 series, one of them will be significant at the 95% level, just by simple. And so you will think that you have discovered something when in fact it's just noise. So you have to look at the process by which the model was selected. You have to try not to fit too many things. Overfitting is a standard problem which occurs, that you try everything and you find the best possible fit. And when you try everything, you are guaranteed to get the wrong result. Causality is key, and actually if you look at consumption function, if you look at the reverse consumption function, both of them will produce equally good fits, because basically the fit depends on the R squared. But the first equation is a good equation because there is a causal chain here. The GNP, the income, does determine consumption. But the reverse is not true. The consumption level does not determine the GNP, and so the second equation is bad. So, but this causal information is outside the data. The data will not provide us with this. So we have to have a knowledge of the real world structure. So this is something which I mentioned earlier. If you run the log of the GDP on the log of the newspapers, you get an excellent fit. The second equation has a weak fit, but the first equation is meaningless. It's just a correlation. The second one is important if it is a causal relationship. That is, the second one tells us that the policy should be that you should spend on education and you will see results of this 10 years later. But the first equation says that you should invest in newspapers, and that will cause instant increases in GNP. That's obviously nonsense. But why do we know it's nonsense? Because we know about the real world. I know and you know that printing newspapers is not going to help increase GDP, because we know about the real world. Otherwise, if this was just X and Y, which is what it is in Var Models, we don't know, we just have the symbols, we don't have the names, and we have the names, but we don't know the reality behind those, then you can't tell the difference between the first equation and the second equation. So, does money cause inflation? There are many papers. Can you find out? Basically, you can't. Granger causality is not a good method, and the way to find out whether money influences prices or vice versa depends on looking at reality, looking at real mechanisms, and it cannot be found out by just running regressions. So there are actually, now I'm coming to some positive results, and I would like to wrap up this talk. So I've discussed this already. There are clues. I mean, it's not that data is useless, not at all. Data is very useful, but you have to use it correctly. You have to, first of all, you shouldn't try one model after the other until you get to the R squared of 100%. That's the wrong methodology, but it's very frequently used. Once you understand what you're doing, then there are ways to use the data to help you in the process. For example, there are many different types of clues which are available, in which we will tell you that there is something happening which is strange. So, for example, if Y determines C, then which is the truth, the GNP does determine C, then the conditional distribution of C given Y will be stable. If C determines Y, then Y given C is stable. So we can look at these two different conditional distributions, it's possible, and see which is stable. If one of them is stable, then we have a clue that the causality is running from Y to C and not from C to Y. This kind of methodology was used by Zahid Asghar. He showed, first of all, that the Granger causality doesn't work, it produces any type of results you want, and then he used this methodology to show that in some cases you can find out the direction of causality. Again, this doesn't determine things, but it just provides a clue, and that's what we are looking for. There are many other tricks which you can use to produce some interesting results from the data. These are path diagrams. There is a whole field of investigation which somebody called Judea Pearl. In fact, Judea Pearl is the father of the Pearl who was murdered here in Pakistan, and he is one of the biggest names in this causality field, and he has invented a lot of new methods which are very powerful and potentially useful. They have made very marginal impact in econometrics, just a few papers, some people have picked them up. So there is a lot of room to use these new methods to try to look for causes, but ultimately you can't rely on data alone, you have to go beyond the data. But the data itself is useful if it is used properly, and Judea Pearl has the proper methods. One of these methods is called screening. So there are, in causal structures, sometimes you have this kind of structure that X causes Z, which causes Y. Now, typically, economists don't, this is called a path diagram. Economists don't study path diagrams. In this kind of a situation, we would say that both X and Z are causes of Y, and so you can regress Y on X and Z, and this will give very misleading results. And this is very commonly done. We just look at everything which can cause without thinking about what is the causal chain. So here, obviously, I can say that X is affecting Y and Z is affecting Y. So in a regression equation, I should put both X and Z. But that will give very wrong results, because actually X is not affecting Y directly, it is only going through Z. So not thinking about causality causes a lot of damage to regression. One of the theses that I examined was based on this mistake. Somebody was looking at the migration from Azad Kashmir and how it affects the crop yield. Well, crop yield is affected by, as a technical thing, it's affected by fertilizer, by weather, by land, not by migration. The migration can only be an indirect effect. Maybe, it raises the human capital. So you have to go through the causal chain. You cannot, running a regression of crop yield on migration will always produce misleading results. You have to go, what does migration do? Does it reduce the labor? Does it reduce the quality of labor? You have to find out. Yield is affected directly by technical factors, and then those factors could be affected by migration. You have to go through the causal chain in order to find out. So currently, econometrics does not provide us with the tools to address causality and structure. Okay, and so it needs to be modified in order to take this into account. So I think I'll stop here and